Hi, welcome to my channel Mathematics Made Easy by Mary MJ. Today I am discussing class 11 chapter 5 complex numbers and quadratic equations. We are moving into the last portion of the complex numbers and quadratic equation, that is quadratic equations. And we are familiar with quadratic equations. Last year we have studied how to solve quadratic equations, and if b square minus 4ac is greater than or equal to 0, we have already discussed how to find out how to solve the quadratic equation of the form ax square plus bx plus c equal to 0. So if the discriminant is greater than or equal to 0, we have solved the equation and we have got the solutions. Whereas if b square minus 4ac is less than 0, we told that last year we studied that there is no solution, but now since we studied complex numbers, we can find the solution of b square minus 4ac in the set of complex numbers, because imaginary roots are there. So we can find what is the solution of ax square plus bx plus c equal to 0 if b square minus 4ac is less than 0, also in the set of complex numbers. So that we will discuss here. We know that x equal to minus b plus or minus root of b square minus 4ac divided by 2a. So if it is less than 0, that means this b square will be smaller value, then only it will be negative. B square minus 4ac less than 0 means b square will be small, 4ac will be greater. In such case, we can write this as minus b plus or minus root of 4ac minus b square into I. That shows it is imaginary by 2a. So if we are writing in this form, we are getting the solution, but in the set of complex numbers. So we will discuss with some examples. Solve x square plus 2 equal to 0. So this is very simple, that is x square can be written as minus 2, and in order to find out the square root, x is equal to plus or minus root of minus 2. What is root of minus 2? Root of minus 1 is I. So we can write this as plus or minus root 2 into I. So now it is in the complex number form. Then we'll move on to that exercise questions. Exercise 5.3. So in that important questions we'll discuss. First one, x square plus 3 equal to 0. It's in the similar way. We can write this as x square is equal to minus 3, or x is equal to plus or minus root 3i. Now another question. 2x square plus x plus 1 equal to 0. So we know the formula. X can be found by using, since first we will check for b square minus 4ac. B square minus 4ac means it is 1 minus 4 into 2, that is minus 1 minus 8 is minus 7. So now we can apply in the formula x equal to minus b plus or minus root of 4ac minus b square divided by 2a, here I. So that is equal to minus b. Minus b means it is minus 1 plus or minus 4ac minus b square. B square minus 4ac is minus 7. So 4ac minus b square is 7. So root 7i divided by 2 into a is 2 into 2, that is 4. So the answer is minus 1 plus or minus root 7i by 4. Then next one, another question. Root 2 x square plus x plus root 2 equal to 0. So x can be written as minus b plus or minus root of 4ac minus b square into I divided by 2a. So minus b means minus 1 plus or minus. How much is b square minus 4ac? B square is 1. So 1 square minus 4 into a is root 2, c is also root 2. That's equal to 1 minus 4 into 2 is 8. So that is minus 7. So we can write this as root 7i divided by 2 root 2. It's very simple. Now next one, root 3x square minus root 2x plus 3 root 3 is equal to 0. So same way, find what is b square minus 4ac. B square is minus root 2 whole square minus 4 into root 3 into 3 root 3. That's equal to minus root 2 square is 2 minus 4 into 3 is 12. 12 into 3. 12 into 3 is 36. So that is minus 34. So this can be written as x is equal to minus b means root 2, minus of minus root 2, that is root 2, plus or minus root 34 into I divided by 2 into root 3. Then next one, x square plus x plus 1 by root 2 equal to 0. So again we'll check for b square minus 4ac. B square is 1 square minus 4 into 1 by root 2, that is equal to 1 minus 4 by root 2. So 1 minus 4 by root 2 is 1 minus 4 by root 2. 4 by root 2 is 2 root 2. So b square minus 4ac is 1 minus 2 root 2. Now what is x? X equal to minus b means minus 1 plus or minus root of 2 root 2 minus 1 into I divided by 2. Then one more question in that exercise. X square plus x by root 2 plus 1 equal to 0. Same way, find what is b square minus 4ac. B square is 1 by root 2 whole square minus 4 into 1 into 1. That is 1 by 2 minus 4, or that is equal to 1 minus 8, that is minus 7 by 2. So x is equal to minus b means minus 1 by root 2 plus or minus root of 7 by 2i divided by 2. This we can simplify because square root 2 is coming in the denominator, that we can simplify and write. That is equal to minus 1 plus or minus root 7i divided by, this whole divided by root 2 is that will come in the denominator, so 2 root 2. Now we will move on to the miscellaneous examples. First one, find the conjugate of 3 minus 2i into 2 plus 3i divided by 1 plus 2i into 2 minus I. So first, in order to, before converting, finding out the conjugate, we have to make in the form of the complex number. Now this is not in the form of a complex number. So first we have to multiply. We have to open the bracket so that 3 into 2 is 6. 3 into 3 is 9. So 9I minus 4I minus 2 into 3 is 6I square. I square is minus 1. So plus 6 whole divided by 1 into 2 is 2 minus I plus 4I minus 2I square, that is plus 2, which is equal to 6 plus 6 is 12 plus 5I divided by 4 plus 3I. Since in the denominator complex number is coming, we have to multiply by the conjugate, that is multiply by 4 minus 3I in the numerator and in the denominator. So that here again we have to open the bracket, multiply these two. So 12 into 4 is 48 minus 36I plus 20I minus 15I square. So plus 15 whole divided by 4 into 4 is 16. 4 into minus 3I is minus 12I plus 12I, then minus 9I square is plus 9. That's equal to 48 plus 15, that is 63 minus 16I divided by 12I minus 12I getting cancelled, remaining by 25. Now it is in the complex number form, that is the complex number is 63 by 25 minus 16I by 25. Now we have to find the conjugate. It's asked for the conjugate. So conjugate is equal to 63 by 25 plus 16 by 25 into I. Next one. Find the modulus and argument of the complex numbers. Find the modulus and argument of the complex numbers. First question, 1 plus I divided by 1 minus I, and second question, 1 by 1 plus I. So we'll start with the first one. So find the modulus and argument of the complex number. Now first thing, we have to convert into complex number form. So for that we have to multiply the numerator and denominator by its conjugate. And we are getting 1 plus I into 1 plus I, a plus b whole square form. So 1 plus I whole square is 1 plus I square plus 2 into I divided by a plus b into a minus b is a square minus b square. That's equal to 1 minus 1 cancelled, remaining 2I divided by 1 plus 1 is 2, which is equal to I. Or the complex number form is 0 plus I. Now we have to find the modulus and argument of the complex numbers. So modulus means it is R. R is equal to mod z, which is root of x square plus y square, that is 1 square plus 1 square, 1 square plus 0 square, which is equal to 1. Now we have to find tan theta. Tan theta is equal to y by x. Y by x means 1 by 0. 1 by 0 is not defined. Therefore theta is equal to pi by 2. Tan pi by 2 is not defined. So theta is equal to pi by 2. It is asked for modulus and argument. So we got the modulus and argument. Modulus of 1 plus I by 1 minus I is 1 and argument is pi by 2. Now the second question there, it is 1 by 1 plus I. Again we have to convert this into the complex number form, so that we have to multiply numerator and denominator by the conjugate. So 1 minus I by 1 minus I, that is equal to 1 minus I by 1 plus I into 1 minus I is a square minus b square. So 1 square minus I square. That is 1 minus I by 1 minus I square is minus 1. So 1 by 2 minus I by 2. Now we have to convert. We have to find what is r and what is theta. R is equal to root of 1 by 2 square plus 1 by 2 square, which is equal to 1 by 4 plus 1 by 4. That's equal to root of 2 by 4, and that is 1 by 2, its root is 1 by root 2. So r is equal to 1 by root 2. Now we have to find what is argument. Tan theta is equal to y by x. Y is minus 1 by 2, x is 1 by 2, which is equal to minus 1. And we have to check in which quadrant it is lying. X is positive, y is negative. X positive, y negative means it is coming in the fourth quadrant. Here theta, here minus theta. So for which value of tan we are getting it as 1, we'll get it for pi by 4, and it is coming in the fourth quadrant. So we have to take the angle theta as minus pi by 4. So what is the argument? Argument is minus pi by 4, and modulus is r, that is 1 by root 2. Now next one. If x plus iy is equal to a plus ib divided by a minus ib, prove that x square plus y square is equal to 1. So x plus iy is equal to a plus ib by a minus ib. So first we have to convert this into a complex number form. So x plus iy is equal to a plus ib divided by a minus ib, multiply by the conjugate, that is a plus ib by a plus ib, and a plus ib into a plus ib is a plus ib whole square divided by a square minus ib whole square. Expanding using our identity, a plus b whole square is a square plus ib whole square plus 2 times a into I into b divided by a square minus I square is minus 1, so plus b square, which is equal to a square minus b square plus I into 2 times a into b by a square plus b square. So that means first part, real part is a square minus b square by a square plus b square plus I into imaginary part is 2ab by a square plus b square. Now we have to find what is x square plus y square. You have to find x square plus y square. X square, x part, what is x? Here we know that the x part is a square minus b square by a square plus b square, and imaginary part is 2ab by a square plus b square. So first we should find x square plus y square is the same as x plus iy into x minus iy, because if we are multiplying this we are getting the same thing, x square plus y square, because x this is a plus b into a minus b form. So a plus b into a minus b is a square minus b square. Same way x plus iy into x minus iy is x square minus iy whole square, and that is I square means minus, so that's why x square plus y square. Since we know what is x and y, we can apply in this. So x plus iy means a square minus b square by a square plus b square, that is x, plus I into y is 2ab divided by a square plus b square into x minus iy, a square minus b square by a square plus b square minus I into 2ab by a square plus b square. Simplifying these two, it is a square minus b square by a square plus b square whole square minus I square into 2ab by a square plus b square whole square. Here I square is minus 1, so this becomes plus, and here this is a square minus b square plus 4a square b square, denominator is a square, here it is whole square, right? So now expanding this, we are getting a raised to 4, then plus b raised to 4 minus 2a square b square, and here plus 4a square b square whole divided by a square plus b square whole square. Now what happens to numerator? It is a raised to 4 plus b raised to 4 plus 2a square b square divided by a square plus b square whole square. So that the numerator is the same as the denominator, because this is a square plus b square whole square, denominator also a square plus b square whole square, which is equal to 1. Now next one, find real theta such that 3 plus 2i into sin theta divided by 1 minus 2i into sin theta is purely real. So we'll start with 3 plus 2i into sin theta divided by 1 minus 2i into sin theta. So we need to find real theta such that this is really purely real. So we will convert into complex number form by multiplying the conjugate, that is 1 plus 2i into sin theta in the numerator and denominator. That is equal to, opening the bracket, 3 into 1 is 3 plus 6i sin theta plus 2i sin theta plus 4i square sin square theta, 4i square sin square theta whole divided by 1 minus 2i sin theta into 1 plus 2i sin theta is 1 square minus 2i sin theta whole square. That is equal to 3 plus 6i sin theta plus 2i sin theta is 8i sin theta, and I square is minus 1, so for minus 4 sin square theta divided by 1 minus I square is minus 1, so 1 plus 4 sin square theta. Now splitting as real and imaginary part. Real part is 3 minus 4 sin square theta by 1 plus 4 sin square theta. Imaginary part is plus I into 8 sin theta divided by 1 plus 4 sin square theta. It is given that this is purely real, so no imaginary part will be there. So we have to equate that imaginary part as 0. So that is 8 sin theta by 1 plus 4 sin square theta is equal to 0, or 8 sin theta is equal to 0, or sin theta is equal to 0. That means theta is equal to n pi, where n element of Z. So it is asked find real theta such that this is purely real. So the imaginary part we have to equate it as 0 and we are getting theta is equal to n pi. Now next one, convert the complex number z is equal to I minus 1 by cos pi by 3 plus I into sin pi by 3 in the polar form. So first we have to write in the complex number form. So z is equal to I minus 1 by cos pi by 3. Cos pi by 3 means cos 60. Cos 60 is 1 by 2 plus I into root 3 by 2. And that is equal to, here denominators are same, that is 1 by 2 plus I into root 3 by 2. 2 is common, that can be taken to numerator. So 2 into I minus 1 by 1 plus I root 3. So here 2 into I minus 1 by 1 plus I into root 3. Multiply by its conjugate. So into 1 minus I root 3 by 1 minus I root 3, which is equal to 2 into, we can multiply the numerator and denominator. So numerator multiplying, we are getting I into minus I square into root 3, then here minus 1, then plus I into root 3 divided by 1 square minus I root 3 the whole square, which is equal to 2 into I minus, I square is minus 1, so I plus root 3 minus 1 plus I into root 3 divided by 1 plus root 3 square is 3. So that this is equal to 2 by 4 means 1 by 2 into I plus I root 3 is I into root 3 plus 1 and plus root 3 minus 1 plus root 3 minus 1. So that the real term we have to split as real and imaginary, that is 1 by 2 into real term is root 3 minus 1 and imaginary is plus I into root 3 plus 1 by 2. Now we have to find, now it is in the complex number form, we have to find what is r. R is equal to root 3 minus 1 by 2 whole square plus root 3 plus 1 by 2 whole square, its square root of x square plus y square, that's equal to root of, here denominators are 4, so 1 by 4 taking out it become 1 by 2. Then here root 3 minus 1 whole square is 3 plus 1 minus 2 root 3, then plus root 3 square again 3 plus 1 plus 2 root 3, then minus 2 root 3 and plus 2 root 3 getting cancelled, remaining 3 plus 1 4 plus 4 is 8. So root of 8 is 2 root 2, 2 root 2 by 2, which is equal to root 2. So r is equal to root 2. Now we have to find what is tan theta. Tan theta is equal to y by x. Y here it is root 3 plus 1 by 2, root 3 plus 1 by 2 divided by root 3 minus 1 by 2, which is equal to root 3 plus 1 by root 3 minus 1. That is tan theta. So for which value of theta we are getting this value? So that we have already studied, that is tan 45 plus 30 can be written as tan 45 plus tan 30. This all we discussed in trigonometric identities. 1 minus tan 45 into tan 30, that is equal to tan 45 is 1 plus tan 30 is 1 by root 3 divided by 1 minus 1 by root 3, which is equal to root 3 plus 1 by root 3 by root 3 minus 1 by root 3. That root 3 getting cancelled, we are getting root 3 plus 1 by root 3 minus 1. So tan 45 plus 30, which is the same as tan 75. Tan 75 degrees root 3 plus 1 by root 3 minus 1, and its equivalent form of 75 degree, that is tan 45 means it is pi by 4 and 30 is pi by 6. So if you are adding pi by 4 and pi by 6, we are getting 5 pi by 12, which is tan 7, which is 75 degree. So actually this angle is 5 pi by 12. So this is the same as tan 5 pi by 12. So now since it is both are positive, that is x axis x value and y value both are positive, this is root 3 minus 1 by 2 and y is root 3 plus 1 by 2, both are in the first quadrant. So we can say that the angle, same angle 5 pi by 12 itself, we have to take it as theta. So in the polar form we can write it as, polar form is r into r, we got it as root 2 into cos 5 pi by 12 plus I sin 5 pi by 12. Next we'll just start that miscellaneous exercise. First question, evaluate I raised to 18 plus 1 by I whole raised to 25 whole cube. So first we'll simplify that I raised to 18. I raised to 18 can be written as, we can write I raised to 18 as powers of 4. How can we write? It is I raised to 4 whole raised to 4 is I raised to 16 into I square. So this is 1. I raised to 4 raised to any value is 1. Then so I square is minus 1. So we can write this as minus 1 plus, same way we have to find what is 1 by I raised to 25. So again we have to write in terms of I raised to 4. I raised to 4 raised to 6 is I raised to 24 into I. So that is 1 by I. 1 by I multiplied by I in the numerator and denominator, we are getting I by minus 1, which is minus I. So 1 by 25, 1 by I raised to 25 is minus I whole cube. Now expanding this, this is minus, both minus sign we can take it out. So minus of, because minus 1 raised to 3 is minus, so 1 minus sign outside, remaining 1 plus I whole cube, which is equal to minus of a plus b whole cube is a cube plus 3a square b, 3i plus 3ab square, so 3i square plus I cube, which is equal to minus of 1 plus 3i minus 3, I cube is minus I, so minus I. Simplifying, minus of 1 minus I is minus 2 plus 2i. Multiplying that negative sign inside, we are getting 2 minus 2i. Next one, for any two complex numbers, for any two complex numbers Z1 and Z2, prove that real part of Z1 into Z2 is equal to real part of Z1 into real part of Z2 minus imaginary part of Z1 into imaginary part of Z2. So for any two complex numbers, so the complex numbers, let Z1 is equal to a1 plus ib1 and z2 is equal to a2 plus ib2. So real part of z1 is a1. Real part of z1 is a1. Real part of z2 is a2. Imaginary part of z1 is b1 and imaginary part of z2 is b2. Now z1 into z2 is equal to a1 plus ib1 into a2 plus ib2. Multiplying a1 a2 plus I into a1 b2 plus I into b1 a2 plus I square into b1 b2, and that is equal to, all the real part we will write on one side, a1 a2 minus b1 b2 because I square is minus 1 plus I into a1 b2 plus b2 a1. Now what is real part of z1 into z2? Real part of z1 into z2 is equal to a1 a2 minus b1 b2, and that is the same as a1 means it is the real part of z1, real part of z1, a2 is the real part of z2 minus b1 is imaginary part of z1 into imaginary part of z2, which we have to prove. So the remaining miscellaneous exercise will be done in the next video. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.